All right, so we are doing some Surds questions using past papers. All right, so we pretty much sometimes we understand the concepts, but it's just a little more challenging when we see it in exams. So this question says, without the use of calculator or table, show that the square root of 6 plus the square root of 2 divided by the square root of 6 minus the square root of 2 is equal to 2 plus root 3. So whenever you're doing surds, remember the first step is to always multiply the numerator and the denominator by the conjugate of the denominator. So we're going to have the square root of 6 plus the square root of 2 divided by the square root of 6 minus the square root of 2. And then we're going to multiply it by the conjugate of the denominator. Hey! Now, since this is a minus right here, the conjugate is going to have a plus. So we're going to multiply it by the square root of 6 plus the square root of 2 divided by the square root of 6 plus the square root of 2. All right, so you always multiply the numerator and the denominator by its conjugate. Now, what we then do is go ahead and multiply going across. So the square root of 6 times the square root of 6, that is going to give us positive 6. Then we're going to go the square root of 6 times the square root of 2. That's going to give us plus the square root of 12. Then we're going to multiply the square root of 2 times the square root of 6. That's going to give us the square root of 12. Then we multiply the square root of 2 times the square root of 2. That's going to give us the square root of 4. And the square root of 4 is 2. In the denominator, you have the square root of 6 minus the square root of 2 times the square root of 6 plus the square root of 2. That becomes the difference of 2 squared, which is the square root of 6 all square minus the square root of 2 all square. So that is going to simplify to be 6 plus 2 in the numerator is 8 plus, now the square root of 12 plus the square root of 12 is 2 times the square root of 12 divided by root 6 square is 4 minus root 2 square is 2. So the denominator is going to simplify to be 6 minus 2, which is 4. So now we're going to need to break up the square root of 12. Let's just write it down here. The square root of 12, that can be broken up as the square root of 4 times the square root of 3. And the square root of 4 is 2. So the square root of 12 is 2 root 3. So what we end up getting now is this works out to be 8 plus the square root of 12 is now 2 root 3. But remember, we had a 2 right here. Look what I'm saying. Since there was a 2 right here, we also need to multiply this by 2. So multiplying that by 2, it's going to allow us to now have 4. So right here is now 4. So let's put that there. So right here, we're going to have 4 times the square root of 3 divided by 4. Now, when you do division, remember, you have to divide the 8. You have to divide 8 by 4 and also 4 divided by 4. All right? So just to make some space, I'm going to erase this side. All right, now finishing this question, we're just going to bring it all the way over here. So we divide now, the 8 divided by 4 is 2, plus the 4 over 4. 4 cancels 4, and so we get root 3. So that proves it, all right? So the final answer is indeed true. All right? So that's how you would do that question right there. Now, the second part of the question is we need to show that when we add these two surds, what we're getting is that the result works out to be 4. Now look at this. We just proved that the square root of 6 plus the square root of 2 over the square root of 6 minus the square root of 2. Remember, we already worked that out. We already worked it out and we got that it was 2 plus root 3. Let us bear that in mind. That is 2 plus root 3. So the only part that we need to work out now, really, we just need to consider this part of it. We just need to consider this part when it is a minus, right? In the numerator and a plus in the denominator. So what we're saying is that part, the root 6 minus root 2 over root 6 plus root 2, we're going to multiply it by the conjugate. And the conjugate is going to be root 6 plus root 2 over root 6. The conjugate have the minus in it, so we're going to multiply by the conjugate, which is root 6 minus root 2 over root 6 minus root 2. My apologies right there. So it's always a conjugate of the denominator. Simplifying, it's going to become, remember, we're multiplying the numerators going across. Root 6 times root 6 is 6. Root 6 times root 2, that is minus root 12. And then we have minus root 2 times root 6, that's another minus root 12. Then we have root 2 times root 2, that become plus. That become minus and minus, make it become plus. So that's plus 2. Divided by, in the denominator, becomes a difference of 2 squared. So we have root 6 times root 6. Remember, that is 6. Then we have minus root 2 times root 2 is 2. So this is working out to be 6 plus 2 is 8 minus 2 root 12 over 6 minus 2, which is 4. Now remember, we already found out that we had already said from the previous part of the video that 2 root 12, we had said this was 4 root 3. So in this case, what we're then saying is that this part is working out to be 8 minus the 2 root 12, we can replace with 4 root 3 over 4. Dividing both sides by 4, 8 divided by 4 is 2, and minus 4 divided by 4 is minus 1, so that's just minus root 3. Cool. So that means that the final answer, I'm just going to write it in black down here. I know it is not following any logical sequence, but that's okay. So the final answer is going to be root 6 plus root 2 over root 6 minus root 2 plus root 6 minus root 2 over root 6 plus root 2. We can write down that this is going to be equal to, remember this part, we found that that was 2 plus root 3. And then the other part, we found that, let's put it in mint green, we found that this part that we put around in mint green, we found that that part worked out to be 2 minus root 3. So when we add them, the 2 plus the 2 becomes 4. And then root 3 plus minus root 3, those dissipate, all right? So those vanish. And so that is how we get 4. All right, so that's how we would do this third question here without having to use a calculator. So as we did that 2008 question right there, and we got that it equal to 4, I want you to then do the same and practice this question and try to show that that is equal to 10. We're not going to work it out here, but I would love for you to go ahead and use the same principle that we did in the first part of the video to show that the sum of the two surds was 4. Use that principle to show that this right here sums to 10.